You've had a long day, haven't you? Your mind is probably still racing with 1,000 thoughts, responsibilities, worries, things you need to remember for tomorrow. But it's time to let all of that go now. Tonight, I'm here to guide you on a peaceful journey through our solar system, where you'll discover the hidden secrets of Jupiter, the mysteries of Mars, the surprising history of our own moon, and the violent cosmic collisions that shaped our world. So go ahead. Close your eyes if you'd like. Get comfortable in your bed. Adjust your pillow just right. And let your breathing slow down naturally. There's nothing you need to do right now except relax and listen. No tests, no pressure. Just fascinating stories from space told gently and slowly. Let's drift together through space and time. Independence Day, 2016. After traveling through the darkness of space for 5 long years, NASA's Juno spacecraft finally arrives at Jupiter. The probe angles its high-resolution camera toward this stormy giant world, and the images it sends back are absolutely breathtaking. The photos returned from Juno are simply beautiful. Stunning mosaics of swirling clouds in shades of amber, cream, and rust. As a human being, you look at these images and think, oh my gosh, look at this. This is amazing. This is coming back from Jupiter, a world 500 million miles away. Let yourself imagine Jupiter's swirling clouds, the beautiful chaos of its atmosphere, storms larger than Earth itself. These are the closest views humanity has ever captured of Jupiter. But Juno didn't travel all that distance, crossing 500 million miles of empty space, just to take pretty pictures. One of its main scientific goals is to peer deep into Jupiter's dark heart and answer a fundamental question that has puzzled astronomers for decades. Does Jupiter have a solid core? You might think, well, of course it has a core. Every planet has a core, right? Earth has a core made of iron and nickel. Mars has a core. Everything does. But it turns out Jupiter might not have a traditional core, at least not in the way we expected. Breathe slowly. Let this mystery unfold in your mind, like a story being told around a campfire. Knowing what lies at a planet's core allows scientists to wind back the clock billions of years to understand how planets formed in the first place, in those chaotic early days of the solar system. If Juno can reveal what's hiding deep within Jupiter, beneath thousands of miles of thick atmosphere, it could completely change our understanding of how this gas giant came to be. If Juno finds a solid core made of rock and metal, dense and compact, it could mean Jupiter first formed as a rocky planet similar to Earth, then just kept growing larger and larger, accumulating gas until it became the giant we see today. But if Juno finds no solid core at all, just gas all the way down, it could mean that Jupiter skipped that rocky stage entirely and formed straight from a collapsing cloud of hydrogen and helium gas. Answering this single question could illuminate other mysteries too. If we can figure out how Jupiter formed, we can figure out the rest of the story of the solar system, how all the planets came to be in their current positions. So how do you probe down into the interior of a planet when all you can really see are the very tops of its clouds? When you can't drill down, can't send a submarine through the atmosphere, can't physically touch the core, well, incredibly, you can use gravity itself as a tool to see the invisible. As Juno orbits Jupiter in its elongated elliptical path, passing close to the cloud tops, and then swinging far out into space, it can sense in its orbit tiny little variations in the gravitational pull of Jupiter. As the spacecraft speeds around this massive world at tremendous velocity, gravitational spikes tug on the craft ever so slightly. And it turns out that some parts of Jupiter are denser than others, pulling harder on Juno as it passes overhead. Feel yourself floating with Juno, weightless in the vacuum of space, peaceful. If Jupiter were just one uniform solid ball, homogeneous throughout, then as Juno passes very close above its cloud tops, at its nearest approach, the orbit, the trajectory would be very smooth and predictable. You could calculate it perfectly with simple mathematics. But in fact, if Jupiter has distinct layers deep inside, or places where there's more concentrated mass, and places where there's less, then it's going to pull on Juno a little bit differently, depending on what's underneath the spacecraft at any given moment. Passing over areas of concentrated mass, regions where rock or metal might be gathered, gives Juno a tiny speed boost, like a surfer catching a wave. So what the engineers back on Earth do is remarkably clever. They basically measure exactly how fast Juno is moving right now. And now. And now. Thousands of times as it completes each orbit. By comparing the expected speed to the actual speed, you can build up a detailed map of where the mass is concentrated inside Jupiter, hidden beneath the spacecraft, as it passes around again and again over months and years. Juno's sensitive instruments begin mapping out the heart of this gas giant, revealing the mysterious core region for the first time in human history. And what Juno found deep inside Jupiter was completely unexpected, something that defied all our theoretical models. Instead of finding a solid core of rock and metal, dense and compact like Earth's core, or finding no core at all and just gas throughout, Juno detected something in between, an amorphous mass, what scientists describe as a fuzzy thing in the center of Jupiter. It's not as solid as we expected if it were just a traditional metal and rock core. But there is definitely something substantial there, something different from the surrounding hydrogen atmosphere. Let this strange discovery settle in your mind as you relax even deeper into your pillow. In the center of the planet, Juno's gravity measurements suggest hydrogen mixed with rocky material, dissolved and blended together in a way we've never encountered before. It's a type of planetary core entirely new to science. Astronomers describe it as fuzzy, somewhere between solid and liquid, neither one nor the other. One scientist put it perfectly. We thought we were going to find an avocado with a nice solid pit in the center. Instead, we found a bowl of chili. It's a hydrogen fluid chili con carne, if you will. Chunks of rock suspended and dissolved in a sea of metallic hydrogen under unimaginable pressure. So none of our carefully constructed models of Jupiter's interior turned out to be correct. That means we have to go back to the drawing board and completely rethink how giant planets form, which is both humbling and exciting for science. One intriguing new theory suggests that Jupiter didn't form from large colliding rocks or directly from collapsing gas, but from something in between. Tiny pebbles, objects less than an inch wide, that were strewn across the early solar system 4.6 billion years ago, like cosmic gravel. Your breathing is becoming even slower now, more rhythmic, like gentle waves. These countless pebbles drifting through the protoplanetary disk came together slowly at first. They accreted, sticking together through gentle collisions, to form a massive object that became the seed, the original core of Jupiter. The swarm of pebbles clumped together over perhaps 1,000,000 years to form one giant core, weighing 20 times the mass of Earth. Already enormous, but still growing. But these small pebbles alone can't sustain a growing planet for very long. Eventually, you need to make a dramatic jump from those centimeter-sized particles up to really large objects. Things like 100 kilometers across, planetesimals, to really kickstart the rapid growth of a giant planet. As Jupiter's core grows larger and larger over millions of years, its gravitational appetite becomes absolutely insatiable, pulling in everything nearby. The cores of other would-be planets forming in the neighborhood are drawn in by Jupiter's immense pull and are absorbed on impact, smashing into the growing giant, causing Jupiter's core to transform dramatically. Huge chunks of incoming rock and ice, some the size of small moons, get mixed up with the hydrogen gas and the original pebbles that built the early core. Scientists think that solid core material that might have existed initially is actually dissolved over time and mixed throughout the planet. Imagine sugar dissolving in hot coffee. Something similar happens to rock under the extreme pressures and temperatures deep inside Jupiter. This unusual mix of rock, gas, and dissolved materials leaves the core in that strange, fuzzy state we observe today, somewhere between solid and liquid, neither quite one nor the other. Your body is so relaxed now, sinking into the mattress, heavy and peaceful. Once Jupiter's core reaches a critical mass, somewhere around 10 to 20 Earth masses, its gravity becomes strong enough to rapidly pull in all nearby hydrogen gas from the surrounding protoplanetary disk, building the massive Jovian atmosphere we see today in just a few million years. The fuzzy core becomes trapped beneath thousands upon thousands of miles of thick, swirling clouds and liquid metallic hydrogen, hidden forever from direct view. And that is what formed Jupiter, as we know and observe it today, the largest planet in our solar system, a world so massive that over 1,300 Earths could fit inside it. Juno's discovery of Jupiter's fuzzy core could completely rewrite the textbooks on the gas giant's early years, fundamentally changing our understanding of planetary formation. But Juno's mission is far from over. The spacecraft continues, orbiting, gathering more data with each pass. We haven't even scratched the surface of the number of mysteries waiting to be uncovered. There's so much more to Jupiter than meets the eye. Layers upon layers of secrets hidden in its depths. As Juno's instruments continue their patient work, they're beginning to reveal an even darker, more dangerous side to this giant world that dominates our solar system. Jupiter's environment is one of the most vicious, most hostile in the entire solar system, and that's primarily because of its incredibly strong magnetic field, the strongest of any planet. And Juno is caught right in the middle of it, bathed in radiation levels that would kill a human being almost instantly. But let's leave Jupiter and its mysteries for now, and drift our consciousness toward another world. A planet that's captured human imagination for generations. A world that seems so close, yet remains so difficult to reach. Mars, the red planet, Earth's neighbor in space, glowing rust-colored in our night sky, and the destination of humanity's most ambitious exploration missions to date. But sending spacecraft to Mars and actually landing them safely on the surface has proven to be far, far harder than anyone initially thought when we first began exploring the solar system. Let your mind wander gently to that distant rust-colored world. It genuinely hurts to think about how difficult landing on Mars really is. The engineering challenges are immense. The planet has earned a grim reputation. It's become something of a graveyard for spacecraft over the decades, littered with the wreckage of failed missions. Roughly half of all missions ever sent to land on Mars have failed, crashed, or disappeared. And that's with our best engineers, our most brilliant minds, and our most advanced technology working on the problem. Think about that for a moment. Even with everything humanity has learned about spaceflight, we still fail half the time when trying to land on Mars. In 2016, the European Space Agency launched their Schiaparelli lander toward Mars. The mission had cost $250 million and represented years of careful preparation and engineering. Everything had been tested and retested. The lander was supposed to make a soft, controlled touchdown on the Martian surface, deploy a parachute to slow down, then fire retro rockets at the last moment for a gentle landing. But something went wrong with the lander's guidance systems. The computer made a critical error in calculating altitude. The parachute detached far too early, thousands of feet above the surface, when it should have stayed attached. Feel your breath naturally slowing. No tension, just listening. Suddenly, Schiaparelli was in freefall, plummeting toward the Martian surface for 33 terrifying seconds, with nothing to slow it down. The spacecraft smashed into the rust-colored ground at 335 miles per hour, hitting with tremendous force. All that remained was a deep, black scar on the Martian landscape, a crater marking where millions of dollars and years of work met a violent end in seconds. Even humanity's most brilliant engineers, the smartest people on our planet working together, have only about a 50% success rate when it comes to landing on Mars safely. The red planet is literally littered with the shattered remains of dead spacecraft that didn't stick the landing. And for NASA's future crewed missions to Mars, missions that will carry actual human beings across millions of miles of space, the space agency must learn from all these past mistakes. There's no room for error when lives are at stake. But any crew hurtling toward the Martian surface in the future will be battling the exact same fundamental problem that doomed many of those earlier robotic landers. The same challenge that makes Mars so uniquely difficult. The Martian atmosphere is 100 times thinner than Earth's atmosphere. 100 times. That means it provides nowhere near enough drag, enough resistance, to slow a spacecraft down, the way Earth's thick, dense atmosphere can. On Earth, landing a spacecraft is relatively straightforward. You can deploy large parachutes that gently glide through the thick atmosphere, using air resistance to slow your descent gradually. The atmosphere does most of the work for you. On Mars, you can use the thin atmosphere somewhat, but its effect is incredibly limited and difficult to work with. It's not enough by itself. Your mind is drifting peacefully, like a leaf floating on a gentle stream. The red planet's thin, wispy atmosphere is actually a problem that's been billions of years in the making. A tragedy that unfolded over geological time. Mars doesn't have a substantial atmosphere today because it's been constantly peeled away, stripped off into space over billions of years due to the lack of protection from a magnetic field. Without that invisible magnetic shield deflecting the solar wind, charged particles from the sun strip away the atmosphere molecule by molecule, year after year, eon after eon. Let yourself drift back through time now, back 4.5 billion years ago, to when the solar system was young. On Earth, a liquid metal core generates a powerful magnetic field, which acts like an invisible protective shield, extending far into space around our planet, deflecting the solar wind, and helping maintain our thick atmosphere for billions of years. Mars once had something similar, but its story took a tragically different path. 4.5 billion years ago, both Mars and Earth formed from the same swirling disk of dust and gas orbiting the young sun. Both worlds were born from the same cosmic material, starting their existence at roughly the same time. But Mars formed in a region of the solar system where building materials, the rocky planetesimals and dust grains, were more scarce, spread more thinly. So Mars's growth was stunted from the very beginning, limited by what was available nearby. Mars ended up much smaller than Earth, about 10 times less massive when all was said and done. And that seemingly small difference in mass turns out to be absolutely crucially important for the planet's entire future. All that extra mass in Earth, all those additional tons of rock and metal, allows our planet's interior to stay warm for billions of years and maintain a churning, rotating liquid core which generates our protective magnetic field. Your breathing is so slow and peaceful now, perfectly relaxed. About 4 billion years ago, roughly 500 million years after it formed, the churning molten heart of Mars started to cool and gradually solidify. The planet was simply too small to maintain internal heat, and with no hot liquid core remaining deep inside, there's no magnetic field being generated anymore. The invisible shield winked out, leaving Mars exposed and vulnerable. Without that protective magnetic shield deflecting them, all the high-velocity charged particles, streaming constantly out from the sun in the solar wind, began picking away at Mars's once thick atmosphere. Slowly, relentlessly, over hundreds of millions of years, they tore the atmosphere away into space, molecule by molecule. Scientists studying Mars today know it's still losing atmosphere every single second, due to the relentless solar wind, even now, billions of years later. So, bye-bye atmosphere, bye-bye protection, bye-bye any chance of keeping liquid water on the surface. With so little Martian atmosphere remaining to work with today, NASA has had to be incredibly creative, remarkably innovative, to get even its robotic landers safely to the surface in one piece. In 2012, the revolutionary Sky Crane system successfully landed the Curiosity rover on Mars, using an ingenious combination of a supersonic parachute, retro rockets, and a hovering crane that gently lowered the rover on cables to the surface. It was an engineering marvel. Previous earlier missions had used parachutes combined with giant airbags that inflated around the spacecraft like a protective bubble, allowing it to bounce across the surface multiple times before rolling to a stop, like a beach ball bouncing down a hill. But that approach, while it worked for small robotic landers, definitely wouldn't work for human astronauts in the future. Imagine being an astronaut, and mission control tells you, don't worry, you're going to bounce onto the surface inside a giant airbag and roll to a stop. It'll be fine. That probably wouldn't inspire much confidence. Feel a slight smile forming at that image, relaxation deepening even more. To land people safely on Mars, NASA needs completely new approaches, entirely new technologies that haven't been invented yet. The Mars 2020 rover mission which successfully landed the Perseverance rover, tested an advanced supersonic parachute system called Aspire, the Advanced Supersonic Parachute Inflation Research Experiment. This technology can rapidly slow down a spacecraft with tremendous force, creating drag equivalent to an airplane jet engine firing at full thrust. It's an impressive piece of engineering. This supersonic parachute technology works fine for robotic rovers weighing a couple thousand pounds. It actually works quite well. No problem at all. But it's not going to work for human missions. Not even close. A crewed lander carrying astronauts, life support systems, supplies, and fuel for the return journey would weigh far more. Perhaps 10 or even 20 times as much as a rover. Not even the most advanced supersonic parachutes imaginable could safely land something that heavy. NASA needs an entirely new plan, a revolutionary approach for future human missions to Mars. One innovative idea being seriously considered is to use Mars's thin atmosphere in a completely unique, unconventional way that's never been tried before. Your body feels so heavy now, like you're sinking into the bed, completely at peace. The idea is this. The spacecraft would come in really fast, diving steeply toward the planet at tremendous speed, getting down to the thickest part of the thin atmosphere close to the ground. Then, instead of descending straight down, it would tilt and go horizontal to the surface, gliding and losing momentum through friction with the air. As the astronauts descend through the Martian sky in this daring maneuver, they would aim the nose of the lander toward the surface, heading for the densest atmospheric layer close to the ground, where there's the most resistance. Then, at the last possible moment, just before impact, they'd pull up sharply like a fighter jet, using friction from the atmosphere to scrub off speed, to bleed away velocity dramatically. Finally, with speed reduced enough, descent engines would fire for the final touchdown, hopefully gentle enough to avoid disaster. Is this a crazy idea? Well, yeah, it's definitely unconventional, certainly outside the box. It might seem a bit wild, but sometimes you have to think completely outside traditional approaches to solve seemingly impossible problems. Right now, NASA's detailed plans for landing astronauts safely on Mars are still very much on the drawing board, being refined, tested, simulated thousands of times. But even if brilliant engineers can successfully get crews onto the surface safely, Mars's thin atmosphere isn't done causing problems yet. That sparse atmosphere has one more dangerous trick up its sleeve that has killed spacecraft before. It causes massive, swirling dust storms that can sometimes cover the planet's entire surface for months at a time, engulfing the world in darkness. Mars doesn't just have dust devils, those small whirlwinds you might see in a desert. It has what some scientists call dust hell, planet-wide storms that block out the sun completely. And these towering clouds of fine particles have actually killed spacecraft before, shutting them down permanently. Your consciousness drifts through Martian storms, but you are safe, peaceful. When Martian winds whip up the incredibly fine dust that covers most of the planet's surface, dust finer than talcum powder, it can have absolutely disastrous consequences for any spacecraft or future colony. The real problem is that these tiny particles get lofted high into the thin atmosphere and then take an extremely frustratingly long time to settle back down to the surface. Weeks, months, sometimes longer. The dust just sits there suspended in the sky, blocking precious sunlight for extended periods. As more and more material gets lifted into the atmosphere by continuing winds, it forms truly enormous dust storms, some of them larger than North America. These storms are so massive, so opaque, that they block out the sun completely and cool the Martian surface. This creates a dangerous temperature difference between the cold ground and the warmer upper atmosphere. And that temperature difference actually causes winds to increase even more, making the storms grow larger and last longer in a vicious feedback loop. NASA's Opportunity rover, a robotic explorer that worked faithfully on Mars for years, learned firsthand about the deadly dangers of being trapped in one of these planet-encompassing dust storms. In 2018, a global dust storm engulfed Mars completely. Opportunity, which relied on solar panels for power, was suddenly plunged into darkness. No sunlight reached its solar panels for months. The rover's batteries drained. Its internal systems grew cold in the Martian night, far below their operating limits. NASA tried for months to re-establish contact, sending signals every day, hoping Opportunity would wake up when the storm cleared. But the loyal rover never responded again. After 15 years of faithful service, Opportunity was gone, killed by dust and darkness. Future human missions to Mars will need to prepare for these storms, have backup power systems, supplies to wait them out. It's yet another challenge in a long list of obstacles. Let thoughts of Mars fade now, drifting to another world closer to home. Our moon, that pale disk hanging in Earth's night sky, that constant companion that's watched over our world for billions of years, seems like the most lifeless, airless, barren world imaginable, doesn't it? A dead rock, pockmarked with craters, utterly sterile and hostile to any form of life. But 3 billion years ago, the moon was a very, very different place, and scientists have only recently pieced together this surprising chapter of lunar history. Let your mind travel back through deep time, billions of years into the past. In 2018, planetary scientists were studying incredibly detailed maps created by the Lunar Reconnaissance Orbiter, a spacecraft that's been photographing every square inch of the moon's surface in high resolution. They focused their attention on the dark patches we can see on the moon with the naked eye, regions that have beautiful, poetic names given centuries ago by astronomers who could only observe through simple telescopes. These regions are called things like the Sea of Tranquility, the Sea of Serenity, the Ocean of Storms. Before we understood what these dark patches really were, people looking through early telescopes thought they might actually be bodies of water, lunar seas and oceans like Earth's. In Latin, mare means sea, so you have Mare Tranquillitatis, the Sea of Tranquility, where Apollo 11 made its historic landing in 1969. Mare Serenitatis, the Sea of Serenity. Oceanus Procellarum, the Ocean of Storms. Beautiful names for what turned out to be something entirely different. But these aren't seas of water at all, and they never were. They're ancient seas of lava, frozen in time, that flowed across the moon billions of years ago in massive, volcanic eruptions. Your breathing is so gentle now, barely noticeable. Imagine standing on Earth 3.5 billion years ago, before life had even emerged on land, looking up at the night sky. You'd see something remarkable. The moon would have a faint reddish glow visible to the naked eye. You'd probably see the eerie light of individual lava flows streaming across the lunar surface like rivers of fire, filling enormous impact basins, hundreds of miles across with molten rock. These volcanic eruptions on the moon weren't like Earth's volcanoes. They were far larger, far more massive than even the biggest volcanic eruptions Earth has ever produced in its entire history. These patches we see on the moon today, these dark Maria, were created by lava eruptions filling in huge basins. Some of these basins are hundreds of miles across, visible even from Earth. These are enormous features, much larger than even the biggest supervolcanoes on Earth. Scientists can measure how much lava flowed across the moon by carefully studying the depth and area of these lunar seas, these Maria. And those measurements, those calculations, can reveal something remarkable about the moon's past, something most people never imagine. They can tell us whether our planetary companion, our lifeless-looking moon, once had an atmosphere. Let this surprising idea wash over you. The moon with an atmosphere. Volcanoes on Earth don't just spew out molten rock and lava. There's also something called outgassing, literally gas from deep underground that comes out along with the lava. You get sulfur gases, carbon monoxide, carbon dioxide, water vapor, and many other compounds released into the air during volcanic eruptions. The same process happened on the moon during its extended volcanic era, billions of years ago. The ancient lunar lava flows that scientists have measured reveal that the moon's surface was covered in active volcanism, in ongoing eruptions, for hundreds of millions of years. This wasn't a brief episode. It was a prolonged volcanic age. The biggest eruptions happened around 3 to 3.5 billion years ago, covering vast areas of the lunar near side, with rivers and lakes of molten rock. Scientists estimate there was enough lava produced during this era to cover the entire continental United States to a depth of 1/4 mile, an almost incomprehensible amount of molten rock flowing across a world smaller than Earth. Your mind drifts peacefully through this ancient lunar landscape. Roughly 3 billion cubic feet of lava gushed out of the moon's volcanic fissures every single year during the peak of this volcanic activity. Year after year, for millions of years, the moon was volcanically active, and these massive sustained eruptions also spewed out approximately 10 trillion tons of gas into space, including substantial amounts of water vapor and carbon monoxide. 10 trillion tons. It's hard to even comprehend that number. It would have been an alien hellscape. Erupting lavas and noxious gases spewing from volcanic vents and fissures across the lunar surface. Gas and steam jetting into the black sky. All of this prolonged volcanic activity probably created a thin but real atmosphere around the moon, an envelope of gas held by the moon's weak gravity. It was still quite thin compared to Earth's thick atmosphere that we breathe, but it was something, a genuine atmosphere. Perhaps something on the order of 1.5 times the density of Mars's atmosphere today. Not much, but not nothing either. And there may have been just enough atmospheric pressure to allow something extraordinary. Liquid water on the lunar surface. Feel yourself floating above this transformed moon. A world with air and water. With this thin atmosphere in place around the moon, water vapor released from the countless volcanic eruptions could condense into actual pools, ponds, maybe even small lakes of liquid water. The atmosphere, as thin as it was, trapped just enough warmth from the sun to prevent this water from immediately freezing solid in the lunar cold. It maintained temperatures above the freezing point, at least in some locations, at least during lunar day. This created a harsh, probably toxic, but potentially habitable environment on the moon 3 billion years ago. An environment radically different from the airless, bone-dry moon we know today. At that time in Earth's history, our planet already had life flourishing in its oceans. Simple, single-celled organisms had been living and evolving on Earth for hundreds of millions of years by that point. So scientists have begun asking an intriguing, provocative question that sounds like science fiction, but is actually serious scientific speculation. Is it possible that the moon had life too, even briefly, even in some limited form? This isn't something we have definitive answers about yet, obviously. We haven't found fossil microbes on the moon or anything like that. But it's not a completely crazy thought to entertain. The moon certainly had the volcanic eruptions necessary to form a temporary atmosphere. It potentially had liquid water. It had warmth and chemistry and time. So there was a window of time, perhaps lasting millions of years, when the moon might have been marginally habitable for the simplest forms of life, if life somehow got there. Let this possibility drift through your consciousness like a dream. Life on the moon. But this warm, wet lunar environment didn't last forever. Nothing does. When the volcanic eruptions that continuously replenished the atmosphere finally stopped, when the moon's interior cooled enough that magma no longer reached the surface, the temporary atmosphere was doomed. The moon's weak gravity, just 1/6 of Earth's, simply couldn't hold on to those atmospheric gases for long without constant replenishment from volcanoes. In just a few million years, a blink of an eye in geological time, but still millions of years, the entire atmosphere was lost to space, molecule by molecule escaping into the void. Any surface water evaporated and was also lost to space, gone forever. Temperatures plummeted without an atmosphere to hold warmth. And any life that might have existed, if it ever existed at all, died out completely, frozen and desiccated. Even though Earth and the moon started out nearly identical in composition, born from the same catastrophic collision billions of years ago, as time passed, they grew further and further apart in character. They followed completely different evolutionary paths, diverging year by year into the worlds we know today. The moon was simply too small. It cooled off too quickly, losing internal heat, lost its molten interior and volcanic activity, and could never maintain an atmosphere or liquid water for long. Earth was large enough to stay geologically active for billions of years, to support a thick, permanent atmosphere, to maintain vast oceans of liquid water, to nurture and shelter life. The moon received none of these gifts because it was just too small, too light. Your mind is drifting so peacefully now, like the moon drifting silently through space. Scientists thought they understood the moon's thermal history pretty well. They believed the moon's small size meant its molten interior cooled within the first billion years of its existence, killing the volcanoes and stopping the core from generating a protective magnetic field. The moon was thought to have died geologically very early, becoming the cold, dead rock we observe today. But new research examining old Apollo samples has revealed we may have gotten our lunar history significantly wrong. The moon may have remained active much longer than anyone thought possible. In 2017, scientists re-examined ancient lunar rocks collected during the Apollo 15 mission decades earlier. samples that had been sitting in NASA's vaults for over 40 years. These particular rocks were about 1 billion years old, formed from lunar lava relatively late in the moon's history, and they showed something completely unexpected when analyzed with modern equipment. Something that contradicted all the models. The rocks contained unmistakable evidence of a lunar magnetic field existing just 1 billion years ago. Billions of years after the moon's magnetic field should have disappeared forever, according to every theoretical model. This is genuinely puzzling. We have a bit of a mystery here that still hasn't been completely resolved. When the moon was still largely molten early in its history, with liquid metal in its core, it could definitely support a magnetic field generated by flowing liquid metal, just like Earth's magnetic field works today. But conventional thermal models, calculations of how fast the moon should cool, say the moon solidified relatively quickly and should have shut off its magnetic field within the first couple billion years of its existence. Yet samples brought back by Apollo astronauts decades ago show the magnetic field somehow persisted much longer than our models predict, lasting billions of years longer. Scientists thought the moon lost its magnetic field around 3 billion years ago, becoming magnetically dead. But the Apollo 15 rocks proved the moon still had a measurable, significant magnetic field just 1 billion years ago, 2 billion years longer than expected. This mystery remains unsolved today, an open question in planetary science. It suggests the moon's interior stayed hotter and more active, with liquid metal persisting far longer than we ever imagined possible for such a small world. Perhaps the moon is more mysterious than it appears. Let these lunar mysteries fade gently as you sink even deeper into rest, your body so heavy and relaxed. Deep beneath your feet right now, as you lie comfortably in bed, buried over 1,800 miles below Earth's surface, deeper than any human has ever gone, deeper than we can ever directly explore. Scientists have discovered something extraordinary in the seismic data. 2 massive regions of unusually dense rock sitting near the boundary between Earth's mantle and its molten outer core. Each one is enormous. One of them is half the size of Australia, an entire continent's worth of material. These mysterious blobs sit like giant anchors near Earth's core, and there's no obvious reason they should be there at all, based on our understanding of planetary formation. Your consciousness drifts down through solid rock, into the deep heart of the planet. To solve this geological mystery, to understand what these anomalous regions are made of and where they came from, scientists needed to somehow examine rocks buried more than 1,000 miles beneath the surface, where no drill could ever possibly reach them, where the pressure and heat would destroy any human-made equipment instantly. But incredibly, ingeniously, they found a way to sample these depths. These deep blobs of unusual material are actually feeding mantle plumes, rising columns of hot rock that ascend slowly through the mantle over millions of years and eventually reach Earth's surface. Volcanoes in places like Iceland and Samoa, among others, dredge up some of this deep material from near Earth's core mantle boundary as they erupt, bringing it to the surface where scientists can study it. It's a precious, rare opportunity to sample rock from the deep interior that we'd normally never get to see or touch. And when scientists carefully analyzed these volcanic rocks, examining their chemistry and isotope ratios, they discovered something absolutely stunning about their age. The samples are incredibly old, 4.5 billion years old, which is as ancient as Earth itself, dating back to the very formation of our planet. They tell us something profound about how our planet's internal structure was arranged in the very earliest days, after Earth formed from the swirling disk of gas and dust around the young sun. Feel yourself drifting back through time, back to Earth's violent birth. The age of these rocks provides a crucial clue to their mysterious origin and to one of the most important events in Earth's history. They date back to a time of monstrous cosmic violence, to the most catastrophic event in our planet's entire 4.5 billion year existence. 4.5 billion years ago, the solar system was still an incredibly wild and dangerous place, not the relatively calm, ordered system we observe today. We were approaching the end of the main planet formation period, but Earth was still growing, still accumulating material from whatever it could gravitationally capture. Back then, you wouldn't recognize Earth at all if you could somehow travel back in time. It would be utterly alien, nothing like the blue marble we know today. For one thing, no moon. Earth didn't have a moon when it first formed. No continents, no oceans, no atmosphere worth mentioning. Just a hot ball of partially molten rock. The young Earth orbited the sun alongside other infant planets, still taking shape, still growing through collisions with smaller bodies. One of them was an object planetary scientists have named Theia, after the mother of the moon in Greek mythology. A Mars-sized world, perhaps 10% of Earth's mass. And Theia was on a collision course with our home. The two worlds' orbits were unstable, slowly converging over millions of years. Your breathing is so slow, so peaceful, like the slow orbits of planets. The Theia collision, when it finally happened, would have been the most spectacular, most violent event you could possibly witness in the entire formation of the solar system. Certainly the biggest, most catastrophic, most important event in all of Earth's long history, before or since. This impact completely reshaped our planet forever. The Earth that existed before the Theia collision was utterly destroyed, transformed into something entirely new. That previous version of Earth is gone forever, melted and reformed. The collision melted enormous amounts of rock, vaporized entire regions of both planets, and threw out over 1 billion tons of debris into orbit around the combined world, creating a temporary ring system like Saturn's. During this incredible impact, these two entire planets were literally broken apart, shattered by unimaginable forces, and then combined into one larger world from the wreckage. Imagine the violence, if you can. Imagine the unimaginable energy released, as two worlds, each thousands of miles across, collide at cosmic velocity. The sound, if there were air to carry it, would have been beyond description. Huge chunks of Theia stayed together in large pieces, even as the now molten Earth began reforming from the debris field. Scientists now believe those mysterious deep blobs of ancient rock near Earth's core, those anomalous regions discovered in seismic data, might actually be pieces of Theia itself. Fragments of that destroyed world that sank down through Earth's molten mantle and have remained near our core for 4.5 billion years, like fossils from a dead planet, preserved inside our own. Earth reformed from the combined ruins of both planets, cooling slowly over millions of years, creating the world we know today, from the ashes of cosmic destruction. You might think a collision like this is purely devastating, purely destructive, with no positive outcomes whatsoever, just catastrophe and chaos. But surprisingly, some incredibly important things that came from this catastrophic impact may have actually led directly to the possibility of life on Earth. Without this collision, without Theia's sacrifice, Earth might never have become the living world it is today. When these two planets combined violently, merged in fire and destruction, parts of Theia's iron core merged with Earth's existing iron core. That means Earth ended up with a much bigger core than it would have had on its own, had it formed in isolation. And this turns out to be very, very good news for us, for all life on Earth, because the core is the ultimate source of the magnetic field that protects our planet from deadly space radiation. Let yourself feel protected, safe, cradled by Earth's magnetic embrace. Liquid metal flowing in Earth's outer core, driven by heat from radioactive decay, and by the cooling of the inner core, generates our planet's magnetic field through a dynamo process, an invisible protective shield extending tens of thousands of miles into space. The sun regularly outputs billions of tons of high-energy protons and electrons in massive eruptions called coronal mass ejections. Without Earth's magnetic field deflecting these energetic particles away from our planet, they would have gradually stripped away our atmosphere over billions of years, molecule by molecule. The same process that killed Mars's atmosphere would have killed Earth's atmosphere too. If it weren't for that active, churning core and the strong protective magnetic field it generates continuously, Earth would look like Mars today. Just a bare, barren, cold desert world without air or water, dead and sterile. Thanks to the extra iron from Theia, from that collision 4.5 billion years ago, Earth's molten outer core is much larger than it would have been otherwise, and a larger core cools more slowly, staying molten longer, potentially for billions upon billions of years. As long as the core stays molten and churning, it continues generating that strong magnetic shield that makes life possible. Because of that ancient collision, because of that extra iron and heat donated by Theia, Earth has stayed geologically active. We have a powerful, protective magnetic field. We are shielded from space radiation. And that's precisely why we're here. Why complex life could evolve. Why you and I exist to contemplate these cosmic mysteries on a quiet night. The catastrophic Theia impact helped potential life in other profound ways too, not just through the magnetic field. Your mind is so peaceful now, drifting through ancient cosmic time like a ghost. After the collision, material thrown into orbit around the devastated Earth, a huge disk of vaporized rock and metal, coalesced over just a few thousand years to form our moon, condensing from the debris ring. The Earth tilted significantly on its axis from the impact and began spinning incredibly fast, rotating so rapidly that a day lasted only a few hours, maybe 5 or 6 hours from sunrise to sunrise. Left to its own devices without any external influences, Earth would have experienced unpredictable, chaotic wobbling on its axis over millions of years. The tilt would have changed erratically, causing wild climate variations, seasons, appearing and disappearing, instability. But the moon's gravitational presence, its constant tug on Earth, stabilizes our planet's axial tilt, keeping it relatively constant at about 23.5 degrees, which in turn stabilizes our climate over millions of years. Without that stabilization, complex life might never have had the stable conditions needed to evolve beyond simple single-celled organisms. The moon's gravitational pull on Earth's oceans creates tides, those rhythmic rises and falls of sea level. And those tides slowly transfer energy, gradually slowing down our planet's rotation over geological time. Over billions of years, the moon has gradually moved farther from Earth, and Earth's rotation has gradually slowed, creating the stable 24-hour day we experience now, a world perfectly primed for complex life to emerge and thrive. We actually owe quite a lot to the moon, and to Theia, its progenitor, for making Earth such a remarkably hospitable planet for life to arise and flourish over billions of years. A giant collision 4.5 billion years ago sounds like complete catastrophe, like the worst possible disaster. But it was probably the best thing that ever happened to Earth, the luckiest accident in our planet's history. Theia, if you still existed somewhere, we'd shake your hand in gratitude, because we owe you absolutely everything. Our air, our water, our magnetic shield, our stable climate, our very existence. We also owe a profound debt to cosmic chance, to sheer blind luck. Because we got incredibly, impossibly lucky, with a literally 1 in a million impact, at just the right angle, and just the right speed. If the collision had been slightly harder, more violent, more energetic, Earth might not have recovered as well as it did. The planet might have been completely shattered, broken into pieces, and we might not be here now to tell the story. If it had been somewhat less forceful, less energetic, the impact might not have made the crucial changes that were needed for life to eventually emerge. No large moon, no enhanced magnetic field, no stabilized climate. We got lucky, remarkably, impossibly lucky in the cosmic lottery. Most planets don't survive collisions like that. Most planets that experience such violence are destroyed or rendered permanently inhospitable, and certainly don't get a bonus moon out of the deal as an added benefit, a cosmic gift. Feel gratitude for this cosmic luck, for the long chain of chances that led to you, for being here, alive, conscious, able to contemplate these mysteries on a quiet night. Earth's huge collision with Theia, that planet-shattering impact, was not our world's first brush with danger in the violent early solar system. Earlier explosive events shaped how our solar system formed, how planets found their final positions. But that is a story for another night. And so we complete our journey through the solar system tonight. From Jupiter's mysterious fuzzy heart to the deadly challenges of landing on Mars. From the moon's lost atmosphere and ancient volcanic oceans to Earth's violent birth in cosmic fire. Each world tells a story. Each planet holds secrets. Each mystery reveals something profound about our cosmic home and our place in the universe. Your breathing is so slow now, so peaceful, barely perceptible. Your body completely relaxed and heavy, sinking deeper into your bed, every muscle loose and warm. Let these cosmic wonders drift gently through your fading consciousness as you sink into deep, restorative sleep, knowing that the universe continues its ancient dance through space, and you are part of that eternal cosmic story, made of stardust, connected to everything. The same atoms in your body were once inside distant stars, forged in stellar furnaces billions of years ago, scattered through space in supernova explosions, drifting through cosmic clouds, and eventually became you, You are the universe experiencing itself. Consciousness emerged from stardust. Sweet dreams among the planets, mon ami. Celeste will be here again soon, with more cosmic mysteries to explore together. More peaceful journeys through space and time to help you rest. Sleep well now. Drift peacefully into dreams, and let the universe hold you gently through the night. You are safe. You are at peace. You are home. You belong here among the stars. Good night. Sleep deep and dream of distant worlds.